To appreciate the idea of continents moving, you have to step outside human timescales and think in terms of a completely different time frame. The continents here are drifting apart at 2 centimetres every year. In my lifetime, we're talking just a couple of steps. Even in 1,000 years, that's just 20 metres. It's only when you start to think in terms of millions of years that you realise just what can happen. "225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent.
Now there was a geological mechanism to explain continental drift.
That's simple.
Once you hear it, it sounds great.
It does sound great.
By the 1960s, both ideas were synthesized into a single theory, the science of plate tectonics. A great discovery that revealed just how complex and dynamic our planet is. Several groups of scientists had concluded that not only is the Earth's crust moving, but the surface of the planet is broken into large, interconnected plates. These plates are constantly in motion, floating on a layer of molten rock in the Earth's mantle.
It seems fantastic. I mean, it seems just too crazy. How could the whole world be sliding around? I can see where people were skeptical.
That's right. That's right.
And that's where Harry Hess comes back into the story. Analyzing core samples and sonar readings from around the Mid-Atlantic Ridge, Hess made an astonishing discovery, a phenomenon almost beyond comprehension. The age of the Atlantic Ocean floor, he determined, was progressively older the further it moved.
Harry Hess was in a position that he could bring it all together. Things were spreading apart and new Earth was being generated. But if you did this for long enough, the Earth should grow. And it doesn't.
The Earth doesn't get any bigger.
No. Harry appreciated the fact that if new Earth was being generated in one area, they have to be consumed or recycled in another area.
The process that recycles the crust of the spreading ocean floor back inside the Earth is called subduction. But as our next great discovery revealed, it's all part of a much larger process, perhaps the most powerful force on the face of the Earth.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in 2 directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move.
This is a view of the Pacific as seen from space. A vast expanse of water that covers almost a third of the Earth's surface. Today, only 1% of this vast ocean is land, and much of it owes its existence to the explosive powers of volcanoes like Convection. 1,500 miles north of the equator, perhaps the most famous group of volcanic islands in the world, Hawaii. Still one of the most volcanically active areas on Earth.
Wilson pulled together evidence from rock dating and the straight line forged by the islands and came up with a single theory. He proposed that Hawaii was created by something called a hotspot, an exceptionally hot region beneath the Earth's crust that was concentrated under Hawaii's Big Island. As the Pacific Plate moved slowly over this hotspot, the immense heat punched through the crust to form a chain of volcanic islands.
So this hotspot is a constant and stationary source of heat beneath the Earth's surface. It's like a blowtorch pointed up at the surface of the Earth. And as the Earth's surface moves over that blowtorch, it punches through, creating a chain of islands and undersea mountains. And that's what we're seeing in Hawaii today.
This theory was a geological masterstroke. It didn't just explain how Hawaii was created. It also confirmed one of the most radical theories of the 20th century, the theory of plate tectonics. They theorized that below the hotspot lies a plume of hot rock which rises up through the Earth's interior. 200 or 300 miles below the surface, it starts to spread out, forming a huge dome. The very top of this is the hotspot. Scientists call this phenomenon a mantle plume. No one really knows how deep it goes, but some scientists have come to the extraordinary conclusion that it may stretch all the way down to the very core of our planet. Heat and pressure from the hotspot had forced up the ocean floor, creating a bulge 750 miles long and 500 feet high. The chain is raised by the swell, but as the islands move away from the hotspot, they slide off the swollen crust, sinking further and further.
An immense gash in the Earth's crust, born of elemental violence. A primordial world of spectacular volcanoes, barren wastelands, and vast bottomless lakes. The Great Rift Valley of East Africa. 3,500 miles long, slicing south from Ethiopia to Mozambique. 35 million years ago, deep below what is now Ethiopia. "2,000 miles down, close to the molten core of the Earth, extreme heat and pressure forced a bubble of liquid rock up toward the surface, where it swelled against the Earth's crust like a blister. But a blister 1,000 miles wide. It tore the landscape apart. Fast forward 10 million years. Eventually, the Great Rift will cleave through the continent. Seawater will invade from the north, and the Horn of Africa will be wrenched off, reborn as an island in a brand new ocean which already has a name, the Afar Ocean.
Among the most dramatic and visible creations of tectonic forces are the lofty Himalayas, which stretch 1,800 miles along the border between India and Tibet. About 50 million years ago, India separated from Madagascar and began a record-breaking race to the north. Normal movement for a plate would be about 1 foot every decade. But the Indian plate was on a fast track, moving more than 29 feet in a century. The massive collision between India and Eurasia thrust up Earth's crust, forming the jagged Himalaya mountain range, and raised the roof of the world. India pushed as much as 1,800 miles into Eurasia and continues to shove north nearly 2 inches a year.
These phenomenal convection currents force the Pacific Plate into its neighbors, driving the process of subduction.
As the plates get dragged by the mantle convection currents, they impede upon other plates. One has to give, so one dives down underneath another, and then the trapped water from its ocean sediment escapes and melts the upper-lying mantle, and that creates hot magma.
It's just another sunny day in California. What could possibly go wrong? The San Andreas Fault. Even though California experiences 10,000 earthquakes every year, most of them are not felt by California's 33 million inhabitants. Only a handful are strong enough to get their attention. The 800-mile-long San Andreas Fault is perhaps one of the most worrisome examples of human tectonic interaction. The boundary of the fault is formed by two plates which move side by side, periodically building up tension. The Pacific Plate on the west and the North American Plate on the east. When the tension is finally released, the landscape shakes and shudders.